All right, let's jump right in. When you hear the term network hardening, it's super easy to picture, I don't know, some boring old checklist, right? But it's so much more than that. Think of it as the art of building a digital fortress, a resilient, layered defense that's actually designed to stand up to the constant attacks we see today. So today, we're going to walk through the blueprint for that very fortress.
But here's the thing, before you can build any kind of defense, you've got to understand what you're up against. You have to know your enemy. So first up, let's get a handle on the modern threat landscape.
The battlefield today is, well, it's incredibly diverse and sophisticated. We're not talking about just one type of attack anymore. You've got these massive DDoS attacks trying to just hammer your front door down with brute force. At the same time, you've got these surgical data breaches, like thieves in the night trying to steal your most valuable secrets. And then, of course, there's ransomware that can literally hold your entire business hostage. The point is, the attacks are coming from everywhere, all at once, and the stakes have never been higher.
Which naturally brings us to the big question, the real reason we're here. In this world of non-stop, complex attacks, how do we get out of this reactive mode and actually build a defense that, works?
Well, the answer lies in this really powerful strategic idea called defense in depth. And the concept is actually pretty simple. Great security isn't just one giant wall. It's a whole series of reinforcing layers, where each layer is designed to slow an attacker down, or even better, stop them completely.
And this right here is the perfect way to visualize it. I mean, think of your network like a castle. The outer perimeter, that's your moat and your high stone walls. Then you've got access control. Those are the guards at the gate, checking everyone's credentials. And deep in the center, you have your core infrastructure. That's the keep, where the crown jewels are stored. See how it works? Each layer protects the next one in.
So, let's start where any good defense starts, guarding the gates. This is all about controlling who and what gets onto your network in the first place. So what does that outer wall look like in the digital world? Well, you've got your routers, maybe for VPN access, and critically, you have a next-generation firewall, or NGFW, doing some really smart traffic filtering. Then, on the computers themselves, you have what's called Advanced Malware Protection, or AMP. Think of that as the last line of defense for the endpoint. These are those first critical checkpoints that all traffic has to pass through.
Okay, so let's say some traffic makes it past the outer wall. Now we have to figure out who it is and what it wants. And this is where the AAA framework comes in. And honestly, this credit card analogy is just perfect. Authentication is proving who you are. That's like showing your card and typing your PIN. Authorization is what you're allowed to do. That's your credit limit. And accounting? Well, that's the log of everything you did, just like your monthly statement. Who are you? What can you do? And what did you do? Simple as that. Now, you could try to do this locally, storing usernames on every single router. But can you imagine what a nightmare that would be to manage? It just doesn't scale. If someone leaves the company, you have to go log into every single device to remove them. No way. So, this brings us to a really crucial point. We need a centralized, server-based way to do this. And the industry standard for that is 802.1x. Here's how it works. A device, they call it a supplicant, connects to a switch and asks for access. Now the switch, which is the authenticator, doesn't make the call itself. Nope. It forwards that request over to a central authentication server using a protocol like Radius or TACACS+. That server looks up the credentials and then tells the switch, yep, they're good, or nope, deny access. It's scalable, it's secure, and frankly, it's the right way to manage who gets on your network. Okay, so we've built our walls, we're checking IDs at the gate. We should be totally safe, right? Well, here's the twist in our story. Some of the absolute worst attacks don't come from the outside. They happen from the inside, by exploiting the network's soft underbelly.
We are talking about Layer 2 of the OSI model, the data link layer. This is the absolute bedrock. It's how devices on the same local network, your LAN, actually talk to each other. And because we think of it as a trusted zone, it gets completely overlooked. But that is a huge mistake, because a crack in this foundation can bring everything you've built on top of it crashing down.
Just let that sink in for a second. If Layer 2 is compromised, Layers 3 through 7 are defenseless. Your expensive firewalls, your encryption, all of it. Pretty much useless if an attacker gets control of the basic switching fabric of your network.
So, this is where the real hardening work begins. We have to secure that core. So for the next few slides, we're going to do a bit of a rapid fire round. We'll look at the most common Layer 2 attacks and then their specific solutions. Problem, solution. Let's go. First problem, MAC address flooding. Here's the attack.
Someone just blasts a switch with thousands upon thousands of fake source MAC addresses. The switch's little brain, its memory table, just completely overflows. And in a panic to keep working, it flips into this fail-open mode, where it basically acts like a dumb hub, just shouting all traffic out of every port. And just like that, the attacker can sniff everything.
The solution? It's called port security. It's a really simple feature you turn on that tells the switch, hey, this port is only allowed to see 1, maybe 2 MAC addresses. That's it. The second it sees more than that, it can just shut the port down. Attack stopped cold.
All right, next up, a couple of classics. With VLAN hopping, an attacker basically tricks a switch into letting them jump into a network segment they shouldn't have access to, like the server VLAN. Even sneakier is DHCP spoofing. This is where an attacker sets up a fake server that starts handing out IP addresses and tells everyone, hey, I'm your gateway to the internet. And boom, they become the man in the middle, seeing all that traffic.
And the fixes are just as direct. To stop VLAN hopping, you turn off automatic trunking. Just disable it, and you use a dedicated native VLAN that isn't VLAN 1. For DHCP spoofing, you enable a feature called DHCP snooping. This lets you tell the switch which ports are allowed to have a DHCP server, and it blocks any fakers from anywhere else. Okay, 2 more, and these are a little more advanced. With ARP spoofing, an attacker sends out fake messages to convince other devices that their machine is the router, redirecting all traffic through them. And with STP manipulation, an attacker can actually hijack the spanning tree protocol and make their own little laptop the root bridge, giving them control over the entire network's data path. Not good. And again, we have specific tools for the job. To stop ARP spoofing, we use something called Dynamic ARP Inspection, or DAI. It works with DHCP snooping to make sure ARP packets are legit. And for the STP attack, we use BPDU guard on all the user ports. If one of those ports ever sees an STP packet, the switch knows something is very wrong and just shuts it down instantly.
So here's the key takeaway, right? For every single one of these major Layer 2 attacks, there is a specific tool to fight it. This is basically your cheat sheet. MAC flooding? Bam, you use port security. DHCP spoofing? You've got DHCP snooping. ARP poisoning? That's what DAI is for. You get the idea. And these aren't some obscure hidden settings. No, these are fundamental, must-have tools for building a LAN that's actually secure from the inside out.
Which brings us right back to where we started, to that big idea. Defense in depth. You've got your endpoint protection, your strong access control with 802.1x, and your hardened core with all these Layer 2 mitigations. It's a continuous, layered process, because at the end of the day, your security is only ever as strong as its weakest link.
And look, if you take one thing away from all of this, let it be this. In today's world, we spend so much time and money building up that perimeter, we forget that the weakest link is often the one place we assume is safe, our own trusted local area network. Because security isn't a product you can just buy off a shelf. It's a process. It requires constant attention and a real understanding of how all these layers work together. So I'll leave you with a question to chew on. Where is your weakest link?